one of the pi bonds, if there's more than one, or if there's only a pi bond in the alkene fragment, is gone completely. And so this particular one was meant to evoke some sort of sense that we're using simple butadiene and that we're using some sort of alkene. These groups are trans from one another. So in our alkene, we should draw in trans here. The other positions are hydrogens. They're on this ring too, just not drawn. And we should have a nitrile group or a carbon-nitrogen triple bond here. And the other thing that's attached to this alkene center I put is a aldehyde. So these are the types of things you should have. Look very carefully at your answer versus my answer. You might have had your cyano group to the left and your aldehyde to the right. That's fine. You might have had this flipped all around. It's absolutely okay as long as you have an alkene with nitrile group attached to one carbon, and at the other carbon, the aldehyde group is trans to it. So if you had any variation on that, it's absolutely okay. If you drew it out with carbon here instead of in this skeletal notation, that's absolutely okay too. But it should have this trans feeling. It should have this number of atoms, and the diene was the simple one. We did quite a few examples of these. This one shouldn't be too terribly difficult, although it is difficult at first glance to make the cut here. We're forming these bonds in all cases. And we saw many, many examples, 2-3 examples using cyclopentadiene. So this is definitely the tricky bit. But if I make this cut, and you might not be able to make it today, but after you practice this for a little while, you'll be able to cut this molecule here, and then look how many carbons are on the left half of it. You know there has to be a diene in it for sure, because the left portion, the way we're drawing these anyway, has to be a diene. And we see that there's 5 carbons here. 1, 2, 3, 4, 5. There's 5 carbons here. This particular compound has a 6-membered ring and a 5-membered ring in it. So 5-membered ring has to come from one of the 2 starting things that we start building with. The other component is a double bond. And for this one, I hope that you had the presence of mind to put the 2 cyano or nitrile groups, as these are called, attached to one carbon, as they are here. So a few little different things here. I'm just going to put a ring around that 5th carbon. I'm going to put a dark blue dot, just as frames of reference where these things are coming from. So I don't think this one should have been too difficult. Hope this one it wasn't either. And this one here, again, 6-membered ring is easily and readily identifiable for us. There's no mistaking where there's a 6-membered ring. And at this point, you should have this feeling that there's always a pi bond left behind from the diene fragment. So out of the 6 carbons, we want to connect 4 of them. In our minds, we want to connect them to some sort of diene partner. And the 2 carbons, we want to connect to some sort of alkene partner. So if we cut this, it's always going to have these 4 carbons with bi bonds and 2 carbons with pi bonds. So if we can cut this and then just put these 2, fill these 2 things in, then we just have to fill in all the other atoms. So for this particular one, these are cis to one another. That actually is a result of the fact that they come from a cis alkene. We're not going to have time this semester to go into these details, why the trans translates into a trans relationship in the ring, or why cis and cis are. Well, we just don't quite have the time, and also I think it's a little bit too much in summer semester to cram in, and it's not important for us actually. The reason why, the way I'm teaching this summer is to think about the Diels-Alder reaction as a synthetic tool. When you mix A and B, what do they give? Or if I give you C, could you actually come up with a reasonable hypothesis where it came from? This particular fragment on the left here that I've constructed, actually, if we look at this, has 6 carbons in it. The diene portion, you can see reflected in this starting material. But the diene, actually, I did something to it. I put 2 extra methyl groups on it. Well, at the 2 position and the 3 position. So there are some methyl groups added on here. And again, if you didn't draw them as CH3s, it's fine. If you just simply drew it something like this, that's absolutely okay. So that concludes our lecture today. I want you to work on the 1, 2, 1,4 conjugate addition reactions of HBr with butadiene. And then we spent quite a bit of time with this Diels-Alder reaction, which also uses butadiene or a conjugated diene system with an alkene system, and we make 6-membered rings in all cases. So these particular reactions, please do your very best on. If there's questions about them, please be prepared in office hours tomorrow at 11 o'clock, or 11:05 is roughly when we'll get started. And today you will expect from me a short introductory video and slides about our next topic. Thanks for just reading those few 4 pages about conjugate addition reactions. Me making a 15 or 20-minute talk about those 4 pages you were supposed to read really wasn't a good use of either of our times. And I think just reading those things should have been a simple logical extension of what we did. Okay, everyone, that's it for today. I'll see all of you again tomorrow morning.